This portion of the project represents the completed system. We have a fan with a heater, and a AC motor represents a water pump. The screen that's coming up is the process screen, which has a large tank representing the barley bed with the turner, which is the upper icon that moves back and forth. There's a water tank fed by a pump, and then the fan and heater. Once we move to this screen, it shows the target temperature versus the actual air temp itself, and we choose a setting, and then the system will try and bring the actual air temp up to that chosen preset. The proportional controller we have will hunt a bit, but eventually it'll bring the measured temperature to the preset. We do this by varying the airspeed, which when the temperature is close, we slow the fan down, and if it's quite a bit higher, then we speed it up, and if it drops below, then we'll stop the fan. As you can see, the fan's slowing down as the temperature gets close to the preset. It got a little bit above, so it added a bit more speed. But the trace is slowly getting closer to the preset value. Now we're changing to a different preset, so the system will try and bring the air temp down to the new lower level. It increases the fan speed to bleed off the heat. At the same time, it will shut off the heater. You can see the trend line starting to drop to our new preset. And as we get closer, the fan will slow down. The water pump, on the meantime, runs on a 70-second cycle where it runs for 10 seconds to fill the tank, then is off for 60 while the tank drains down. This represents the level of water that's necessary to keep the barley nice and moist. Here we're almost at the preset temperature, so the fan is slowed down to barely a crawl. Now we're going to change the preset again to another temperature. And you can see the target preset line has gone down, and now the system is trying to bring the temperature down to meet that. So it's added some more fan speed, and you can see the trend line dropping. And just like the other changes in temperature, as the trend line gets closer, it slows the motor down. This is the system screen, which shows what everything is up to, what's running and what's not. Currently it's just the fan, and the turner's going back and forth. On the plenum of the fan, you can see the Rosemount temperature transmitter. It's got a probe that runs up into the plenum, sits over top of the heater, and that's where we get our analog temperature signal back to the Scada system. It's a resistive temperature device which connects to the transmitter, and then the transmitter gives us an analog 4 to 20 milliamp signal back to the system. This screen is the control screen. It shows the different temperature presets you can select, and allows you to put the fan in auto or manual mode. It also displays whether or not the fan is running or if the heater is running. This is your main control for the temperature setting of the system.
Alright, so essentially what we have on this screen, we're in local start mode, and as you can see on the left side of the screen, is the temperature readout, and then on the right side of the screen is the fan RPM readout. And then as you can see, the lower 4 buttons allow us to, they have preset temperatures on them. And so we have a 30-degree preset, 40-degree preset, 60-degree preset, and then an 80-degree preset. And then he just hit the back button. Alright, and so right here what we have is the main screen. Essentially what it tells us is like what's on and what's off. And as you can see right now, the temperature probe is running, the fan is not running, the pump is not running, and the heater is not running. And so as you can see, bottom 3 buttons allow us to go to the home, local start, and then system settings. Alright, as you can see, we're back on that local start screen, and we are currently in manual mode, and manual mode allows us to manually turn on the pump ourselves. We can manually turn on the heater, and if we wanted to, we could really select one of our preset temperatures. And as you can see right now, a preset temperature has been selected, so our temperature is currently dropping as our fan speed is currently increasing. And he is just playing around, hitting the heater button. And as you can see right now, if we're on the main screen, you'd see our pump and our heater buttons are both operating. And he just disengaged the pump, and as you can see, the temperature is going up. So as you can see, we're still in manual mode, and right now we just transitioned over to auto mode, and as you can see, he put it on auto mode start, and he selected 60 degrees preset temperature. And right now back to the main screen, as we can see, the fan's running, the heater's running, and the temperature's probe's running, and the heater was just disengaged. So clearly that's a sign that it's hit 60 degrees. Okay, and as you can see, the fan is on right now because it's trying to regulate the temperature and keep it to where we need it to be. Alright, here we go. It's finally starting to drop a little bit. Okay, and now that we just turned it to 30-degree preset, so as you can see, the fan speed increases. This way we could cool the system down even faster. And as you can see on the main screen again, our fan is running and the temperature probe is running. And those are the only things. And so now we're at system status. So what we have here is a temp air percentage, and so essentially what that reads out to us is a difference between like the set point and then the actual temperature. So that's how that works. And then on that screen we also have our temperature, our actual temperature, as well as our set temp. And so how the error works is it just gets like the difference between those values and computes it into a percentage. On the local start screen, 60-degree temperature preset was selected. As you can see, the fan is running, the heater is running as well. And now we're on the system status screen, and the temperature error percent is quite a bit high. And due to us choosing 60 degrees preset, that causes our heater to be turned up, and then our fan is on but not as fast as it would be if we were trying to reduce the temperature. And now the system's starting to balance out. The set temperature and the temperature are getting close in value, and as you can see, the error is getting very small too. And right now the fan is running and the temperature probe is running.
Okay, so now we're going to talk about the programming of the Scada blocks. Now we switched over to the real active view of everything, processes that are happening. This is our subtraction block, or our error block. It takes in the set point and the actual temperature It goes into a multiplication block, which is a proportional block, and that actually scales the output to reduce the error. Then goes into this scale block, which is used to feed our actual scale reading. Then it goes into this normalized block, which then converts it from this multiplied signal to 0 to 100 range. Then goes into an absolute value block, because occasionally the multiplied signal ends up being negative, and that will throw off the values. It's negative because the set point becomes negative, and this is showing that it's actually a 4 milliamp signal currently. It's at the minimum fan speed, as can be seen. It's very close to set point, as can also be seen. So the line we're looking at right now actually takes the signal from the VFD and turns it into a signal for our readout. This takes the temperature input from the temperature probe, this normalized block, and converts it into the actual red temperature, which currently, as can be seen, is about 52 degrees Celsius. So this is showing that the system is currently in auto control. It has an e-stop built into all of these auto control settings, or manual control, so that if you hit the e-stop, every system shuts down. This is the auto processing area, so it has the auto start button before it starts the auto processes, and it also has the motor start contact and everything latched, dependent on its control. That's why there's the 3 separate lines. So once the pump turns on for 10 seconds, the motor starts for 10 seconds, then it'll be turned off, or be turned on, and will be latched once the fan heater latch is on. So you can see that currently right now the heater is off. That's because the set point and the actual temp are very close. It turned back on because the set point went below 5160, so it's below, so it ended up being true. Now it's increasing past our determined value, so it turns the heater back off. You can also see that this block is turned off and on by the auto manual settings. Currently this block states false, the auto heater on and off block states false, so it actually turns off the heater. Down here is just another one for the pump, so this ladder logic will determine whether the pump runs or not, which is on a cycle for 70 seconds, so once every 70 seconds the pump will turn on for 10 seconds. So down here is our error set point selection. So we created a block that will take in values from our HMI, and we'll actually scale it accordingly to what we select. So right now 60 is set true, so temperature output is 60. This is the auto processing area. So the top block, the ton, is to turn on the pump for 10 seconds. Once the pump turns on for 10 seconds, it is then turned off. The fan and heater are then turned on to complete the process. This process cycles every 70 seconds. Now that we scroll down, we can see the tank level, count up, count down. Now that's controlled by these timers down here, and will accordingly, when the pump is running, we'll charge it up to its maximum value, and as the 70-second interval elapses, it will decrease it back down to its minimum value. This cycle goes on for the pump will start up for 10 seconds. As you can see, it just went up to 10, close to 10, and then every 6 seconds it'll actually go down 1. So over the process of 60 seconds, which is the countdown tank level timer, it will decrease. Now this one shows the animation counter that we created. So this one actually moves our turner back and forth in the PC system. Again, it's a count up, count down timer. Uses two different tons to control its up and down movement, and then also has a reset. So after our period of 40 seconds, it will reset the entire system. And after 20 seconds, it'll latch it in its one condition, so it will keep it so that it can go forwards or backwards. And that's how we get our turner to move back and forth.
Checking on the motor, we can see that once we reach the required temperature, the motor will eventually start to slow down, reaching to about 100 RPMs. This is the pump system we have set up right now. We can set it to auto or manual, depending on the choices. To the fan here, we can see that it's getting slowly reduced. Here's the HMI control for the pump. We can see the pump is slowly stopping right now. Checking back on the fan. As we can see, we have a heating element in here that with restricted airflow that allows the airflow to be heated to approximately the set point.